Welcome. You're listening to Under the Surface, a podcast where we have in-depth discussions on computer-aided techniques in drug discovery. Welcome, everybody. My name is Chris Williams. I'm the host of the podcast here, Under the Surface. My co-host today is Dave Thompson. Good day, Dave.
Hi, Chris. Thanks for letting me be a co-host just for today.
Thank you. Just for today, it's always.
Well, but you said just for today.
Okay.
Sorry. Thank you for having me.
Thompson. Our guest today is Steve McCloskey from Nanome, and he's here to talk to us about the Nanome product and 3D visualization and the next phase of 3D visualization and AI, if I'm not to be mistaken.
Yeah, generally the technological future of the nanoscale, how we approach it, especially for drug development, proteins, molecules, all that.
So, can you tell us, what your background is, how you got to where you are, and what you're kind of doing? That might get people getting to know you and, what your product is about as well.
I could share some of my background. Yeah, no problem. So I actually was a nano engineer back at UC San Diego. Did a lot of research using, great characterization methods like electron microscopes, X-ray diffraction, a lot of things that let you analyze things at the nanoscale. But whenever I tried to use software, I thought it was really lacking, especially in that third dimension and trying to get hands-on. So I ended up, kind of going out it myself in 2014 and ordered a virtual reality headset, the Oculus Developer Kit, and then started just building prototypes to try to get molecules in there, proteins, material science, crystal structures, really anything at the nanoscale.
And that was part of your thesis work, or just something you did sort of on the side of your actual thesis work?
Yeah, so I'm kind of an anomaly maybe here in the science world. So I went there for undergrad, and so I got to work basically from freshman year in a material science lab during undergrad. So have a few years of lab experience there. And then this was kind of like my senior year. I started getting really into this and really drop my other side things that I had going on and focus everything into making the ultimate nanoscale interface. And so, my PI at the time, Ken Vecchio, really great mentor. But yeah, I don't have a graduate degree. I have about 3 grad classes that I took just for personal knowledge. But yeah, no doctor, just good bachelor's in nanoengineering.
Well, that's interesting, because most of the people in our field we've talked to do have PhDs and lots of research experience, but you're coming from a sort of computer engineering perspective, in a sense.
Kind of like a tech forward focus, grew up around computers, knew a bit of programming and wanted to just make this product, this thing that didn't exist. And so, I wanted it to exist. I looked, it didn't exist. And so I had to make it. So really that was the angle that I started out with. But then over the past, 10 years, I've gotten to work with amazing people, PhDs, some of the smartest people in the world. And by getting hands-on with their molecules in virtual reality in Nanome, I've learned just so much. So it's been like a PhD in of itself, just kind of working in industry with all these smart people.
Definitely. You get to encounter hands-on what people are actually working on. So, but you're going from thinking about making this product, on the side, and then devoting yourself full time to it. And now it's 10 years later. How did you go from, I'm just going to start programming this, to now I've got a product, right, that you can actually sell to people?
Before we get there, I want to go back one step and just try and understand a little bit, what was it about the current way or the way at the time that people interacted with these things that drove you to want to build something that was different?
Yeah, so the whole department of nanoengineering at UC San Diego is the first department of nanoengineering in the world, and the ethos behind it is to engineer at the nanoscale. So I saw that as a call. I need to be the ultimate engineer, but engineers get hands-on, and you can't get hands-on with molecules. It's not really possible. You can do some chemistry, you can do some lithography, like semiconductor industry, and you could make things that are nanoscale, sure. But actually to get hands-on and have this building block kit, it just wasn't possible at the time. So, I grew up playing video games. I tried, the super old school virtual reality big helmet in 1997. kind of had all these ideas that stuck with me. And I, tried Primal and a lot of other, Crystal Maker, Vesta. Yeah, they're fine programs. It just wasn't enough of an engineering program for me to go out and build. Like there's sci-fi, like Tony Stark, an Iron Man. He pulls up the periodic table and starts making these new things. He asks Jarvis, this AI assistant, to make things for him, and I thought that was beautiful. It's like how things should be. I should be able to talk with my system. It should give me three-dimensional information that I could get my hands on and manipulate. Why aren't we living in that world? So that's the world I want to live in, and we're out here making it.
Very cool.
So it's also the 3D world you're living in, and you also alluded to talking to the 3D world, having the 3D world as an interactive partner.
Yeah, I think it's going to be many partners. Right now in a research collaboration, you have many people that you work with, each one with a different specialty. We could have a singular assistant that maybe just encompasses multiple personalities, but I think it'd be more fun to just have a few different AI assistants that have their own personalities, embodiments, and specializations. You say, hey, find me similar structures to this one. It'll go and it'll get all the kinases that are kind of similar to it. And that same program could then spin up generating molecules, calculating chemical properties, different things. You could use the assistant for sort of the full stack. But I do think that as we refine these AI technologies, each one is going to be a little bit better at different things, and they're going to be a bit more specialized. So you're probably going to be working with multiple.
Okay, so
I feel. I was just going to say, Chris, I'm sorry. I feel like we jumped to the future again.
Yeah.
Trying to talk to guests, and then we jump, 10 years into what they did. So just walk us through the early years, Steve. You decided to build this thing. So you built a prototype, and then what did you do?
Yeah, I showed it to all my friends. I think that's a good first step when you have a prototype. So I brought it into the department, started showing my other nano engineering friends, showed my PI. Everyone was, I think, generally pretty interested in this as a thing that could be pretty cool, but the prototype was really rough. It didn't show too much.
Did the interest take them to the, and all I need now is $100,000 just to get me to the next level? Like, were they that interested? Or
I wish. No, I kind of bootstrapped it. It was more like, yeah, cool, keep it up. And I did keep it up. And then eventually I got a few friends to join up with me. And so that was kind of the foundations of, not just being a solo person, because I was doing this by myself for a bit, and then ended up trying to get lab space on the UC San Diego campus in order to kind of build a cohort, like a collaboration where we get a bunch of people together and make this thing better. So I talked with the art department, and the art department on campus kind of got displaced a bit. Like they're building so many new buildings at UCSD that they ended up putting the structural materials engineering building, which is pretty much a nano engineering building, on the footprint of the art department's part of the campus. And so as part of that, they ended up giving art studios in about 1/3 of the building to the art department. And unfortunately, a lot of those sat vacant. So I would always be passing them by, like, what is going on? Why are all these empty art studio, labs here? And I talked with a few people I knew in the art department. They, connected me with other people in the art department. Ended up talking with Ricardo Dominguez, Sheldon Brown, eventually Benjamin Bratton, and they were very supportive. They kind of gave me a shot, let me get the lab space for a quarter. Then of the quarter, the new PI was going to take it over, and I ended up negotiating with him to be almost a grad student. It's the art department, so they're more flexible when it comes to things. But I was able to keep going with my project after I graduated. And so by that point, I had a few friends. They had another year left to graduate. So they were helping out. I was kind of full time. Ended up taking a few grad classes just to bump up my current knowledge, and just kept growing. Kept working with different smart professors at UCSD, computer science, nano engineering, cognitive science, background friends. So a lot of different ways to approach the problem, but they're all really needed because there's a user interaction, usability issue. There's a scientific rigor issue. There's a optimization of computer graphics. all these things need to happen in order to make a great product. And if you don't have a multidisciplinary team, it's really hard to do that.
Okay, so you got some interested friends together. Did you start a company at that point, or was it still kind of loose affiliation?
Yeah. Yeah, I did an initial incorporation in 2015. So this was, kind of carried it in 2015. Started getting a few different small contracts, things here and there. Ended up getting a bigger
Like,
one with the math
like
department.
what kind of contracts?
Just helping out with some nano engineering projects and kind of being the virtual reality experts and helping to connect different things that they were doing. There was this virtual glove project where they were trying to make gloves that would have like flex resistive sensors in order to use for virtual reality input or sign language recognition. But really, that lab, their main goal was working on this organic, flexible, strain sensor type of material, and that's what they publish on. That's their big thing. So everything else, in terms of getting getting the use case and showing how it could be used for VR, we helped out with that. But then the big one was the math department. So we had been talking with different people in the math department about what we were doing, and they were very interested in vector calculus. So, three-dimensional calculus, spheres and toruses and in different sort of three-dimensional parametric shapes that you plot with UV parameterization. A lot of these concepts are very hard to understand. You draw them on a chalkboard and everyone's just kind of squinting at it like, is that 3D? But then, you get one little change. You change the bound of U and V from 0 to 2 pi to 0 to pi, and it cuts in half. That type of dynamic interaction was just impossible. So we set out in 2016 now, right? So there's like a lot of minor things and prototyping and all this along the way. But 2016, we got this grant with the math department, and we ended up making our first on-store product called CalcFlow. So CalcFlow is still a three-dimensional graphing calculator. It was the first. It's still kind of the only 3D graphing calculator for calculus in virtual reality. And we made it available for free now.
CalcFlow. So people could Google CalcFlow and go get it.
Yep, CalcFlow. It's on the desktop-based virtual reality system. So the Steam VR, the Oculus desktop. We haven't ported it over to standalones just because we're mostly focusing on the molecules for the past 8 years or so. But it's a great product. Now I'm going to teach my son mathematics and vector calculus when he's ready for that.
He's like 3 months old now, right, Steve?
He's 5 months old.
Yeah, and with this,
he's almost ready.
That's the first video game you're going to give him.
Yeah, exactly. Oh, hey, you want to play a game, buddy? Here, put this on. Oh, here, plot the equation. Exactly. Here, click on the torus.
Other kids are talking about something called Mario Brothers.
For sure, in terms of educational purposes, it sounds very amazing to make concepts that are boring to people, or even in the high school or early college level where people are having trouble or maybe not interested, to help visualize these things and help people who maybe not even go into science see this at a younger age and understand it maybe a little bit more than the scribbles of chalk that they saw in math class.
Definitely. Yeah, talking with people, there's like two big areas where I think people drop out of STEM. One of them, if they're into chemistry, it's organic chemistry. Yeah, they struggle in OChem, they end up going to biology or maybe just switching their majors entirely. Something where they don't need to take the OChem anymore. In the other area, if they're going into engineering or physics or math, vector calculus, actually. It's multivariable calculus. So it's kind of like the last math class that you might take as an engineering or physics students, I think, take a bit more, and math majors obviously never stop. But for most engineers, vector calculus is the last math class that you end up taking. But it's a very challenging one because it involves a lot of three-dimensional thinking and three-dimensional visualization. And some people just don't have great 3D visualization capabilities in their head. My philosophy is that if you train yourself enough using virtual reality, you'll start dreaming it, you'll start seeing it. You can train your brain to get better at it.
I mean,
but without that sort of input, it's not gonna. You're not going to get anywhere.
Yeah. So, I mean, and the math department employed this. Did they find, did they get a good uptake from the students? Did they get a good response?
Yeah, actually, the students loved it. It was like a summer school type of class when we ended up helping out for the first program. So it was 2016 summer. Everyone was playing Pokemon Go on the streets. I remember that. Kind of running around with their phone catching Pokemon, and we were down in the basement entrepreneurial center developing CalcFlow and working with the math students hands on, like every day, getting feedback and showing them the modules and connecting with the lessons that they were doing. And then at the end of that summer, we launched CalcFlow. Actually, it took until December when we officially got onto the Rift store because it needed the controllers, which came out in December of that year. So we were kind of like a launch when they came out with the virtual reality controllers for the Oculus. And yeah, from there we mostly focused on Nanome and developing the molecules. I got Novartis in 2017 as a big collaborator, and from there we ended up expanding with a lot of other pharmaceutical and biotech companies. So yeah, CowFlow was kind of the last big push that got us a bit of funding, kind
Mhm.
of got us over that hill in order to make prototypes even better, get us a little bit of money for computers and stuff. And then we finally, broke into the pharmaceutical biotech
Mhm.
market, which we'd been trying to do for a long time. It was really those connections at, the former GNF site,
Oh
Novartis in
yes,
San Diego.
yes, yes. So that
Well, I feel like I was just gonna say we jumped ahead a little bit again. So the CalcFlow stuff, I'm assuming because there was a grant attached. Was there an evaluative component to CalcFlow? Like
So
students not using CalcFlow were worse performing than students using CalcFlow, or was there no evaluative
yeah,
component to the
there was
grant?
a bit of that. We didn't really get to do a full study on that, and then we tried subsequently. But the professor that we worked with was mostly a teaching professor instead of a research professor.
Right.
This was all basically an alumni donation that ended up going to us to actually make this. So it was a little bit less rigorous than like a true NIH type of grant
Mhm.
or something like that. It was very flexible, right? The department wanted to make it happen. They got a donor, and
Yeah.
they just made it all happen. We made it happen, and everyone was very happy with it. And now CalcFlow is freely available for the world.
Yeah, that's cool. And then, so you described kind of wanting to break into the modeling side of things, the connections into the biotech and the pharma. Like, what was that being driven by your background as a nano engineer? Was that being driven by what you felt was like a market that you could help with, or like what was the motivator there?
Yeah, the motivator. That's a good question because I set out to make Nanome as the home for nanoscale design. You could build anything. It could be metal organic frameworks or new materials. It could be proteins and new drugs and molecules. But really, the most challenging issues I think are all related to biology. We have billions of years of evolution. These complex structures do things that we still don't fully understand. They're all very complex, three-dimensional shapes that move, take on multiple conformations. And every single atom that's part of that protein and every atom that's part of the molecule, there's going to be some importance with everything. So you have this, atomistic, detailed perspective that you need to understand as these things are dynamically interacting in three-dimensional um, ways with quantum mechanics at play and everything. It's so challenging that I thought, hey, this is an area where people really need this stuff. People have been working on protein visualization in 3D and cave systems and such for many years. This is how we develop drugs. As a kid, I guess to go way back, a lot of people in my family had cancer, and I really wanted to cure cancer. So I actually came into UCSD as a biochemistry major, switched to nanoengineering when I learned we had the first nanoengineering department in the world. But this idea of like wanting to cure cancer, cure different diseases never really went away. So biology being at the forefront of the most complex issues where people need help, the most impact to actually save lives and help the world. It all just kind of lined up, but we needed people, right? I wasn't very familiar with a lot of people in the pharmaceutical and drug development research world, but now I am,
so
and I
so
have a
how
lot of
so
friends
so
and
how did that
colleagues.
happen, right? Because like the thing is, in these industries, there are groups of people that know each other, and it's hard to get your foot in the door. Sometimes, especially when people don't
It was.
necessarily know you, you're not associated with a very well-known, say, drug discovery lab in a university. So how did you get your first contacts in, say, GNF or Novartis or, in the pharmaceutical industry in general?
Yeah. So I mentioned that we were in the basement, like startup accelerator, building Cockflow and all that. There were other programs associated with that. And there was one person in particular that was a mentor. He's still a really great mentor and connector around UCSD. His name's Greg Horwit. We ended up taking him on as an advisor. But before that, before there was any, hey, equity, we love working with you, all that, he was just so happy and friendly to help us out. So we told him what we were trying to do, and he said, "Okay, I know someone. He's the former CIO of Novartis. He's retired now. Let me introduce you." And so I meet him, Jeff Odell, another great person. So he was living in San Diego at the time, so it was very easy. Now he's moved over to Texas, I believe. But we ended up getting him into virtual reality, showing him the proteins, and he was blown away. He's like, wow, like this is amazing. This is going to help so much. I know a structural biologist at GNF that would love to see this. And so then Jeff set up a meeting with GNF where we got to go on site and demo a room of people, one of them being the structural biologist, and they really liked it. And we ended up, continuing to work with them. We showed them prototypes, and then kind of recollected, made the prototypes better. Went back, showed them prototypes again, and so they saw the pace of development at which we were able to improve things. And I think they were really, sold that this is the team that could make it. So yeah, that was Glenn Spragan from GNF Novartis. That he's still a big enthusiast for Nanome and everything 3D. And I think as a structural biologist, it makes sense, right?
Mhm.
You're always caring about the structure and trying to convey that structure to your team, get your team to understand the structure so they can all do their job better. So Nanome was really a hub to help bring everyone together, understand the structures, and then it really just went from there. Can I change this amino acid? Can I mutate it? Can I change this R group on the molecule? Can I run docking?
Mhm.
Can I do this? Can I do this? Yeah, it just really
Request after
exploded in
request
terms
after
of the
request.
potential.
Yeah, sounds
Exactly.
Yeah,
familiar, eh?
yeah, yeah. Sounds
Yeah.
familiar. But I mean, that's always a good sign that people like it and they want more. And
Mhm.
and actually, I guess the opportunity to interact with people actually working in the field was probably helped you quite a bit, in a sense you understand their workflows, the things they want to do, um, as opposed to working in more of a vacuum, right? Not interacting with the end users.
Exactly. Yeah. And we had been building prototypes based on, my knowledge of nanoengineering. Actually, right before working with GNF, we were working with a professor at UCSD in the Skaggs School of Pharmacy, Zoran Radic. And he's also a structural biologist, loves the structures. I met him when I saw on the Facebook group for like UCSD research, somebody posted an image of him in front of a TV with the big protein, and he had the goggles on,
Mhm.
the virtual reality headset from back in the day. And I was like, wow, this guy's like already doing it. I wonder like how far ahead he was. He was trying to get this other program to work, and he couldn't get it to work. So like he really wanted virtual reality. And when I went to his office, he had the 3D glasses from the last 20 years. It all just lined up and different things. Like he had been getting every single thing that could help him with 3D. If it looked like it was going to work, he had it. He had the red, green. He had the stereo active where it would be flickering. And eventually we found him, and he was like, yeah, I can't get this thing working with my program. I said, all right, here is our program. Why don't you try it out? And so he tried it on our headset. I gave him a build on a flash drive for him to try at home. It worked in his lab. And then it worked, and he was really happy. And then he kept asking for, can I get this protein, that protein? So everything that we were able to show Zoran, we ended up, showing GNF as well, which was the capabilities of the platform. So that was kind of a stepping stone to really getting into industry, was to work with, people in academia that are doing similar research.
Yeah, because that way
That's very
you've
cool.
developed the application, towards those workflows, and you've already got some things to show people, right?
How much of what you were able to show people in those early years was dependent on the progress, like the rapid progress that was made in the hardware, right? Because I imagine you have a vision for this thing, and it is futuristic, and it is guided by the movies to some extent, right? I want a minority report like interface, or I want to be able to talk to someone and have them minimize something for me. And so how much of what you wanted to do was hampered by the technology you had at the time? And how do you manage that as you were going into some of these early meetings?
Yeah, definitely a lot of that was hampered. So in the first headset I had, the Oculus Developer Kit, it didn't actually have controllers with it, and so I was
Yeah.
experimenting with.
When again was that, Steve?
So
That was
that
what,
was
16,
2014.
17? 14.
Yeah, so
Okay.
14, it didn't really have controllers. There was Elite Motion, which was an infrared camera that would kind of track your hands. If you try to move anything, though, it was really bad. So it wasn't quite there. There was a 6 Sense Razer Hydras, which were really expensive at the time. But then that computer science professor I talked about earlier, that he's actually been working in virtual reality for like 30 years now. He was an expert, and I'd been working in VR for 20 years, so he already knew everything. He had a bunch of 6 Sense controllers, so we ended up trying them, but that still wasn't really enough. It was the HTC Vive Pre. Actually, we got because we founded the Virtual Reality Club at UCSD. We ended up getting early access to the hardware of the HTC Vive, and that included controllers for the first time. That was a game changer because they were accurately tracked. They were kind of clunky, like holding a big old school TV remote in your hands. Didn't really feel great, but it worked. It worked really well compared to anything else we had done. So that allowed us to develop Cockflow entirely. That allowed us to build prototypes where we could actually grab and move the molecules and make them larger and things like that. And then eventually Oculus came out with their controllers, I think, December of 2016. So it must have been the Vive Pre was late 2015, early 2016. So it was kind of like a 1 year period almost where we just had the HTC Vive, but didn't really have the Oculus Rift controllers. We had the Rift headset, but it didn't have the controllers yet, which was so frustrating. But of course, we tried to get early access developer kits, all that type of stuff. We still do that, where we try to get early access developer kits to get on the next generation of hardware so that we're ready by the time it comes out.
Are the hardware folks supportive of the community of entrepreneurs that are growing up with the technology? They're happy to provide these development kits. They're happy to provide early access, or is it kind of you'll get it when everyone else gets it, sort of thing?
It's hard. Yeah, you gotta convince them that you're the 1 out of X number of projects that they're actually going to be giving hardware to. A lot of the things were gaming at the time, super big focus. Hey, play a video game. You can do this. You can do that. So we were a little bit of a minority where we say we want to help develop drugs and do science and help out some education as well. And that was not popular at the time. We worked with the Oculus for Business people when, before they had any sort of business initiative, it was just gaming. We kept saying, we need this in enterprise. We need to get it, approved by IT security. Could we not have Facebook.com here? Like, could we do something about that so we don't need to whitelist it? All these things we told Oculus, Facebook, Meta, all of them, as well as HTC. We try to have good relations with all the vendors, and so we just kept telling them what our customers needed, and eventually both of them listened to us and ended up having business and enterprise offerings, which are much more mature today. So yeah, it's a combination of the hardware being there and the hardware improving that always helps us out, but also the firmware and the software from the hardware manufacturers. Those being improved helps us out a lot too.
But it seems to me that you have to drive that, right? Based on what your customer needs.
We're still, we're still advocating on behalf of our customers, all the things that they want. And I think, eventually these things do get built, but, they have their own priorities where 10 people ask for the same thing, but, we're asking for something else. Maybe they don't prioritize it as much, but we've had long relations with them. So eventually things do get done.
When you were doing so I'm assuming it was sort of demos to the GNF folks, and then they ultimately ended up trying it themselves. A good chunk of what we do at CCG is supporting people in using the tool in the service of their science. And for us, it's fairly straightforward now. There aren't many people who are unfamiliar with the form factors of computing, right? A keyboard, a mouse. Yep. So you can usually navigate them through. Maybe there's some language specific considerations if someone's using a Mac and someone's using Windows. So you just, control command sort of thing. But for your kind of interface, like what's the ramp up like for, okay, here's a wand, or here's a controller, or here's this thing that's like a remote, or here's a thing that's like a handset. How does that go?
I think most people pick it up really well within the first 30 minutes of exposure. If they've already had familiarity, a lot of people will say, yeah, I played Beat Saber. I get that so often. And I'm like, great, you played Beat
Nice.
Saber. So it's kind of like that, but instead of shopping blocks, you just reach and grab a protein. Here's the button that you reach out and grab. Before mixed reality, when it was all virtual reality, they couldn't see their hands and they couldn't see the controllers. That was much more difficult. But now you could use the cameras on the headset to see the real world. That helps out a lot, because then they could look down at their hands, and when we're showing them the buttons, they still see it even though they have the headset on. But some people pick it up very quickly and it just feels natural, it feels intuitive. And I think that's the ultimate interface that you're going to get, is something that feels natural, feels intuitive, just feels like real life. You're grabbing, interacting with things. The hand tracking is getting there, but that's also somewhat of a new modality. All this hand tracking plus eye tracking that the Apple Vision Pro has, it's very different than how Oculus and HTC and the other VR manufacturers have made their devices, where although Meta, Oculus, they support hand tracking, it's different when you have the eye gazing, because the eye gazing is kind of like a mouse movement, the cursor, and then the pinching is like clicking the mouse. But then there's other times where you just use your hands to like grab and move things instead of as a mouse. So it kind of switches between these modes. I think at the end of the day, Apple probably thought about this a lot, and I think it's maybe more intuitive than anything else. Some people don't like controllers. They pick up the controllers, they say, I don't play video games, I don't know how to use these. And then once you show them this button's like grabbing and this button is like clicking a mouse, it's not too complicated. You don't need to use all the thumb buttons and be spamming things. Sometimes kids will go in. I've demoed a lot of people, all ages. The kids will just press every button and they'll figure it out in like 10 seconds. They're like, oh, this one does that. Oh, perfect, great.
No fear.
You're golden.
I guess I kind of get, so I was going to ask, if do you have a correlation with age? Someone who's young can pick it up. People who've played video games before, but someone who maybe hasn't played very much video games and maybe used like a Wii once or twice, do they have a more difficult time picking it up?
I'm not sure if there's a direct correlation like that, but some people do pick it up much more rapidly. I think that those people are maybe more used to the 3D graphics and maybe video games. But the people that don't play video games, older people that didn't grow up with computers, they still get it. Like if they're motivated about molecules and proteins, they'll get through the rest. Doesn't matter what age they are. Yeah, and I've had people in their 70s even just pick it up and just be so happy. They're smiling, they're interacting, and they're like, this is amazing. Like I'd studied this structure for 30 years and I didn't even see this detail. I just saw in 10 seconds. But I get that from all ages. People that are doing their PhD, just finished their PhD, have been in industry for 10 years, 20 years, 30 years. They have that one protein that they've looked at for so many hours in 2D. They rotated it around. They tried to get all the information, different types of views, secondary, tertiary, primary structure, all of that. And within 30 seconds, they're seeing something new for the first time. And we're happy, they're happy. It's just all a good time on that demo.
There's something to be said for that. Even looking at things in 3D, Dave and I have looked at the same structures over and over again. And occasionally when you look at it the right way with the right surface on it, you do see something new. So it's a testament to how difficult it is to represent something in 3D on a 2D screen. And I think, having this thing we can actually hold with your hands and rotate, makes a difference. I mean, it's an optical illusion. Yeah. I don't know if we've probably all done this. You're looking at a 3D image on a 2D screen. You're rotating it around. Everything looks good. Then you look away for a second, and you come back and you rotate your mouse, and it rotates in the wrong way. Because your mind has built up that image of how it's rotating, right? To your point, Steve, that we've got that image we've had to build up by looking at structures over a long time. Dave and I are both modelers. Worked in this too. You can probably look at a 3-dimensional object on a 2D screen and get sort of an idea of what's going on. Other people have even more of a hard time. But even an experienced person, you look away for a minute, you come back, you rotate it, the image you've built up in your mind is now gone, or it's wrong and changed somehow, and now you rotate and it kind of goes in a different direction.
Yeah, the 2D window, like a monitor with rotation, it's very unnatural for building that 3D model in our head. Because if you think about the real world, we either see things directly with two eyes and it looks 3D, or if we only had one eye, it would be the movement of our head or walking through the world. You could build a three-dimensional perspective by having movement, which is why the rotation kind of gives you the 3D perspective. But even if you had a head tracking where every time you moved your head left and right, and the protein kind of relatively let you look at different angles of it, that helps tremendously for depth perception. And when you combine that with both eyes and the head tracking, it's an amazing experience where you immediately just see the details, and you're never fooled by an optical illusion in VR because you're always looking at it in stereo.
So you're saying it's kind of moving around a little bit sort of on its own naturally, so you can sort of maintain that idea of 3D, or as your head moves, you see it differently.
Yeah. So if you look at your monitor and you move your head left and right, nothing changes. But if you put a sensor on your head, and so every time you move your head to the right, you update your view as if you moved a little bit to the right. That could actually give you a pretty good 3D understanding with a 2D monitor. But it's pretty uncommon, and I think that it's marginal value compared to really being in virtual reality with the full stereo display and being able to move, walk around it, grab it, scale it, rotate it with your hand. It's just
I went to the video of the showing your software. It was pretty cool. You had 3 different people grabbing the protein, moving it, zooming it in. I think we'll put the references in the resources in this podcast, so we can go to those papers and go to the links in the papers. You can really get an idea. It's so hard to describe a 3D graphical thing during a podcast.
This is one-dimensional. Yeah, this is like 1D information. You have a stream of information as voice, and then you go to a monitor and it's 2D, and then you go into virtual reality and it's 3D, and so it's really hard to convey that with just one dimension here. But check out the links that they're going to be sharing and see the videos. It'll give you the next level of understanding, and then try it out in virtual reality, and you'll really see it.
I like that those comments on eye tracking, because Dave, that explains, Dave calls himself a nervous modeler. He'll put a protein up on the screen, and he'll have his mouse, and he's always rotating it a little bit. The protein is always moving a little bit in 3D. It's never static on the screen. So I think that's what you're trying to do, maybe subconsciously, Dave, that you're doing it consciously, but that's what's actually getting achieved, is that you're emphasizing trying to emphasize the 3-dimensionality of these things. As soon as it becomes rigid and static on the screen, then you lose that.
It's always invisible. No, I think I picked that up when I was working in industry, and just in case anyone will walk behind your open door, I just wanted to make it believe like I was working, I was doing something, right? So always keeping the protein in motion. Like, he's thinking there. Yep.
So we have the rock and roll feature in Moto to do that. You don't have to move it.
I just turn that on now, wouldn't I?
This demo feature in our software Mo, where you just click rock and roll, and then all it does is take the view and slowly rocks and rolls the protein around in an animations fashion for demos and whatnot. But I guess it could be, if the boss is coming.
Steve, we work a lot with medicinal chemists, and sometimes I've heard it said, perhaps unfairly, that medicinal chemists oftentimes think in flatland, right? They think in 2D structures exclusively. And so sometimes we've shown them, Mo, or they've experienced some other modeling platform, and the idea that your molecule that you sketch in ChemDraw or your drawing package of choice has an extent in the 3D world, right? This is sort of, and so do you get the same sort of thing, right? How do they feel about seeing the small molecules in 3D? Is there a similar sort of, this is cool, this is interesting?
What happens the good ones, they work in 3D. They need to understand how these molecules they're designing actually fit. But we hear that a lot, because 2D you get different information, especially related to like synthesis, where if you're able to compare a bunch of 2D snapshots and you easily see all the changes just happening on the side of that, then synthesis wise, much more clearly, maybe what base you could work, or, not like an acid base, but like, what starter scaffold you could work with, and then what you might need to add to that. And it makes a lot of sense. But when you think about what this is actually going to do in a person's body when they ingest it, how it's going to interact with the protein structure, then you really need to think 3D. So yeah, the good ones that I've seen, they are really great with 3D, but then there's other times where they just have everything in 2D. But yeah, I hear that a lot. Chemists thinking 2D, but I also hear that chemists can't use computers. But I've seen plenty of medicinal chemists that are fantastic with computers, and they're kind of like a computational chemist in a way, but they can design molecules and synthesize. They're really just the full stack drug developer chemist, and I think that
Right.
that's a good direction.
Yeah, no, for sure. And I think what's interesting about this whole kind of thread of representation is, the majority of marketed drugs were developed prior to structure-based drug discovery, right? The majority of marketed drugs are actually GPCR inhibitors, which didn't have structures for the longest time. So the 2D medicinal chemists were the ones really driving the industry without any 3D information at all, because they were synthesizing molecules. I think it's, I think what's really interesting about all of the different tools that we bring to bear now is just how layered that representation is in our minds. Right? It's the VR insight. It's the traditional modeling insight. It's the 2D insight. It's the random interaction you had with the super excited person that was happy to tell you something about some literature that wasn't just published yet. Do you know what I mean? It's like all of this sort of sits in the back of your brain, and your brain is making this n-dimensional representation of it that helps drive forward that progress, which I think is I think it's just extraordinary. That's all. But to that point, and Chris kind of alluded to this as well with the video where you have like multiple people. Tell us about the use of Nanome during the pandemic, because I think collaboration is a really interesting piece of what you do, right?
Yeah. So back in 2014, 15, we were aware that there could be pandemics. I think Ebola was a big kind of scare at the time. And we thought, hey, if there were to be a pandemic, how would people work very quickly together in order to come up with cures? Also around that time, I was thinking that eventually Nanome would be a like full remote virtual type of meet and VR company. I didn't know how that was going to happen. And then 2020 rolled around and everything started changing very, very quickly. So in January, I was snowboarding in, I think, Big Bear or Mammoth with some friends. And we saw, hey, viral pneumonia out of Wuhan. And, Taiwan is taking these measures. And I was like, oh, wow, okay. If Taiwan's getting serious, like, they understand Mandarin. They probably, saw something that was very alarming to them. There was the whole 2003 SARS outbreak. Hope this isn't something as bad as that. So I kind of kept a close eye in January. It kept getting worse, although, I think all the politics was, it's not going to be a big deal. Don't worry about it. Our office at the time was in Miramar, San Diego, next to the Marine Corps Air Station. And we ended up, kind of seeing the first plane come in with the people that came from Wuhan. And I think there was a thing in the news, like they didn't quarantine them. They just kind of like let them out accidentally for something. Like they were supposed to quarantine them on base, but then like people were just walking around San Diego. I'm like, oh dude, no way this is going to get contained. This is going to get bad. And then I had a trip scheduled to Europe in February, and I was just like, it's going to be weird. Should we go? But a couple of my colleagues were already there and decided to, go and meet up with them. And I was like, all right, be prepared. I brought like a little mask with me. And like day one, we go to the conference and everyone's talking about the first case in Lombardy, Italy. And we're in Austria. So we're like next door. And it's just, we're all scientists. We all kind of know what's going on. We know that there's this viral pneumonia, and now it's, gone outside of mainland China and it's actually entered, Europe. And I think everyone was just like, yeah, let's not shake hands. Like, let's kind of, be a little bit distant. And so we got, a lot more serious, and we were already kind of probing out, who's working on researching COVID at the time. But made it back right before the lockdown. I think 1 week before they said no more flights between, Europe and America, and, kind of went through the whole, the first onset of the 2020 pandemic. I made it back right before that. And I was just like, wow, I'm glad I made it back. I didn't end up going to the office for the whole week. So it just kind of quarantined. So I didn't, infect my whole company just in case I had anything. And then, the whole, everything happened, everything changed. And then we just went remote immediately. So it was a week after I got back. And then we've been a remote company since. So that's how that happened. At the same time, we were reaching out to a bunch of people working on COVID, and there were more and more and more every day. Where, by the time the actual lockdown started, everyone was just locked down trying to work on COVID. So we had like NIH researchers that were trying to do something because they were on a grant and just wanted to help and couldn't get access to their labs. We had private companies, small size, big size, everyone. And so if they were working on COVID, we tried to help them out. We worked on some detectors. We worked on protease inhibitors, or help clients work with protease inhibitors, analyze the mutational changes of the coronavirus, especially the spike protein. Researchers in Australia, Data61, CSIRO, they were using Nanome to real time see how this virus was changing. They'd get the new genetic information, they'd map all the mutations on the homology model of the spike, and then they'd just look at it in virtual reality and they'd say, oh my God, this is going to cleave. This is going to make it so much more infectious. And so when they got the Omicron data on a Friday, they got together. This was Mike Kuiper with some colleagues on the weekend. So he was in Nanome all weekend looking at the spike protein. And by Monday, they had a report ready for the government to show them just how infectious Omicron would be based on the computer modeling and virtual reality visualization that they did, to help understand those particular mutations that made it much more infectious. So that was already influencing policy. So yeah, a lot of the projects that we help with, I think maybe will take some time. COVID hasn't gone away, and I think that these drugs will eventually get approved for some treatment that is hopefully better than Paxlovid or some of the standards right there. But yeah, we still help out a little bit with COVID. It hasn't completely gone away, but definitely a big surge with everyone trying to do research on it in 2020, 2021. And we just tried to help as best we could.
I still used Twitter at the time, and there was such a kind of exciting community of people who had a variety of different skill sets who were all coming together. I remember watching the COVID moonshot.
Oh yeah.
From Post-Era, and just a really exciting, like, here's a bunch of data, and it's open, and you can look at it in whatever you want, and you can do whatever kind of analysis you want, as long as you're clear with everyone what you did and how you did it. And they were getting free crystal structures of fragments, and it was just such a super exciting kind of citizen science opportunity for so many different people in different fields. It was really, really exciting. It's super funny. I thought I was right about this, but I just double checked while you were talking. So your colleague Sam, who I've met a couple times, right? Sam is Sam a co-founder?
Yeah. So Sam was one of the friends back at UCSD. So we played rugby together back at UCSD, and we're always chatting about different like physics things. He was electrical engineer, I was a nano engineer. We had a very smart rugby team. And we're good friends. So when I told him that I was starting this thing up, he's like, oh man, like, could I help out in any way? And so he kind of started out helping a little bit and then got more involved. But yeah, he's been great.
So I met Sam for the first time. Must have been the week of like March 11th, 2020 or something like that, because myself and my colleague were in San Diego for some customer visits. And actually, we went from San Francisco to San Diego for a workshop, and that's where I met Sam, because he came along to the workshop.
I must have been self-quarantining that week. I think I was working remote.
I'm not sure. The workshop was very busy, and my colleague and I were very aware of the fact that the news reports were beginning to suggest that something was going on. And I think every single conversation we had with a customer started with, "Yeah, I'm trying to stockpile toilet paper." And that was weird in and of itself. And there we were. You're right.
It's
my colleague was based in Montreal.
Do, unfortunately,
just stock up on toilet paper. Let's calculate the burn rate, folks. It's a very Canadian thing to do, Chris.
What is that? I didn't hear.
Well,
Stockpiling
no
beer.
one was stockpiling beer.
Beer
One of our
and
colleagues
maple
had a
syrup.
good picture. He had a picture of a checkout line. One person had a shopping cart covered with toilet paper. The other one's filled with beer. And it was like different priorities.
Exactly. But it's funny because Sam was at the workshop for at least a day, and I remember him telling me where he's from and what he was working on. And then he whipped out one of the Oculus sets. Like he had it in his backpack, and he was like, "Here, we could try it," and it was cool. That was my Sam story. So you've gone completely virtual now. You're a virtual organization.
We still have an office in San Diego. People come in about 3 days a week, but half of our company is not even based in San Diego. And people voluntarily come back there. We never made a force back to the office type of mandate. It's more, we have an office and we have a sort of a hardware and, demoing part of the company where we, have to have physical hardware and we, it's great to have a place to meet up and, show, different customers or potential customers all the latest and greatest or just colleagues. So yeah, it's good to have an on-site. So we technically do have that, but for the most part, we are remote. Meeting through 2D video calls as well as virtual reality. We do a lot more Apple Vision Pro now as well.
I think you said you were going to hook Chris and I up with some of those. I believe that was what you said when we spoke last week. Anyway,
you got to call Tim Apple. He'll hook you up.
No, so I have questions about that. But tell me about the collaborative component of modeling, right? Like if I model with a standard modeling package, I'm sat next to someone, or I'm presenting perhaps. So I've done that in the past where you present on a screen and you're manipulating a mouse and you're trying to make a point, right? Like here's an important motif, here's an important interaction. I've labeled it. Here's how it looks. Here's the vector we're thinking of moving in. What do you think? I understand that you can have multiple people interacting with a model through Nanome. Is that true? And could you talk a little bit about that?
Yeah, absolutely. So I could have my headset on here. You could have your headset on over there in Canada. Chris could have his headset on, or you could both even join in 2D and just kind of be in companion mode while you watch me in virtual reality. And then I could pull up the protein structure. I could hand it to you. So I could say, "Here, Dave, check this out," and then you could grab and scale it and move it around and say, "Oh, what's going on with residue 382? Is that forming a hydrogen bond there?" And then I could go in and say, "Oh yeah, it looks about 3 angstrom. Let's make a measurement. Let's check it out." So you could definitely have that sort of collaboration. If you already have a bunch of information you're trying to go through, we have a few ways of presenting that. You could have sort of like 3D slides, let's call them, where you have all these snapshots that you show and different interactions and highlighted parts, different colorings. And you could show that. And when you show it in 2D, like if you're doing that to people that have joined in the mouse and keyboard version of Nanome on a monitor, or you're just doing that over a video, they could see it really well because when you're in VR, you're rotating and manipulating it with your hands. And so you're able to zoom in and show them like exactly the part. And then, you could do the wiggling and, kind of give them the stereo. It's much better when everyone's in virtual reality together or mixed reality now, where you can see the world around you. But yeah, when you have that protein directly in front of multiple people, everyone's on the same page immediately. There's no, I totally know what you're talking about. And then, a week later, you ask them about it and, they weren't on the same page. In virtual reality, because it's there, it's right in front of you. When you point at it, they see where your finger is pointing exactly. It's that atom, it's that residue, it's that R group. This is what we're looking at. It just becomes so much more clear in terms of communicating three-dimensional data.
I guess it's the depth issue. When I point with a mouse, I'm pointing in a place in space, but it'd be anywhere behind that mouse.
Yep.
It could go quite far.
Exactly.
Is there like a state representation? Like we have a collaborative session, and then I save them. What do I say? Can I save something?
Yeah. You could save it in a variety of ways. You could export as PDB if you've made like mutational changes. You could save the whole workspace as a Nanome binary file. So it'll be all the coloring, all the 10 proteins, different colors, this, that, everything. Whatever you had, you save that workspace. Next time you load it up, it's exactly the same. And then the cool one, which I don't think many people really have this, it's a spatial recording feature. And so you could
Mm.
actually make like a 5-minute clip where you're, going around showing the protein, saying, I did this, I did this. Here are my top compounds. I did a virtual screen of a billion compounds. These are my top 100 of those. I've selected these 10. You could walk them through the logic of everything you're thinking. And then they play it back and they see your avatar. They see your avatar pointing at things. They could pause it. They could grab the structure from your avatar in their own time and rotate it around and then click play. And then everything goes back to how it was and the avatar continues. So yeah, you could
Interesting.
have this fully immersive
So,
like 4D
so
recording.
you can sort of like, as you're, summarizing your work, a sense, I did this, and you're speaking. I guess you're recording at the same time, right? Vocally,
Mm-hmm. Yeah, yeah. You
and
just hit a
they
button.
so they're watching it. What to them looks like a video, in a sense, but it's really this 3D virtual, play. And then at any point they can stop and say, well, they've got the actual data as you had it, and they can go off and do what they want with it at that point.
Exactly. Yeah, they could fork it, and 3 minutes in, they say, "Wow, that was a really good part. Let me just go ahead and export the structure or save it for later." And then
Mhm.
they could play back, or they could just stop the whole video at that point. So yeah, it's like a play, where every single actor is moving in 3D. And so it's not you're in a video, right? It's a full three-dimensional recording
Mhm.
that moves over time. So it's like a 4D recording.
It's that level of recursive simulation. It just bakes my mind. It's super interesting. It's
Yeah,
super, super
it's
interesting.
great. But it's like simple things in a way where you say, "Hey, if we're all in virtual reality together, could we record this?" And like that,
Mhm.
yeah, recording it, right? We've made plenty of
Yeah.
videos on YouTube, but it's not the same. You can't go to YouTube and like, reach into the protein and like grab it out and then like download it and change it. Once it's been recorded, it's just in a video format. But if you keep everything in the PDBs, and whenever the avatar is moving the PDB, you keep that data intact, so that when they pause it, they could actually download the PDB. Then you could spin it up into Mo, and you could do some calculations, and then bring it back into Nanome, and then make your own recording or show it to your
Mhm.
colleagues or get them in. So it becomes a part of the scientific ecosystem when you
Yeah.
keep the scientific data intact during the recording process.
Yeah. Is there any link between I don't know, just after the pandemic, must be a couple of years ago now, I gave a presentation. Well, it was an ACS session on emerging technologies, and I talked about some of the crowdsourcing stuff I'd talked about in the past. And one of the things that had just come out was uh, people embedding scientific games inside games, right? So the act of doing so, Eve Online, right, the massive
Mhm.
space opera. It's been running for a very long time. Persistent simulation. Um, they embedded um, uh, they embedded a piece of science, some image recognition um, games into the act of Eve Online. So I would work, and then I would come home. I mean, I didn't actually do this. I don't play Eve. I read about it, which is even more
Mhm.
sad. But I come home. I don't play Eve. But if I did, I would play Eve, and then inside that game, I would go and play a fake game where I was actually doing image classification for a machine learning approach. Like, is there a thing you could do on the virtual reality side that is akin to this, where you basically bring back those two threads, the gaming thread back into the science using the VR technology?
We've talked about it over the years. I think that there'd be a lot of fun. Fold It was actually a big one in
Yeah.
the 20 teens I played with a lot,
Yeah.
and I thought that was great. Crowdsourced protein folding. Of course, we have AlphaFold and AI tools now, but even Rosetta Fold, I think they were trying to use some of the user input data in order to train these algorithms to be more effective. Whether any of that helped now, 15 years later with all the AI tools available, doesn't matter. It helped bridge a gap, and it was fun and educational. And I think it got a lot of people interested in protein sciences. So I've thought about a lot of different things, like everybody crowdsourcing and developing their own drugs and molecules. We saw with the post-era moonshot project how that went, where it's like a 2D web portal. You upload all of your molecules there. Um, there's like an intellectual property aspect of that, which I don't think anyone cared about when it was height of the pandemic. But I think for most drugs, if you design a molecule and it ends up actually working and helping save lives and makes money, then you would probably want some attribution for that. So we started thinking about ways to attribute people if we were to have like a crowdsourced drug design type of thing going on. I've talked with the RCSB Protein Data Bank. There's some pretty interesting things that we could do relating to like auditing the protein structures. Not every protein structure uploaded is correct. And unfortunately, a lot of these, folding models, AlphaFold and such, use these potentially incorrect structures then to train their models.
Yeah.
So, if you're able to clean up that data, then you could, obviously share correct information as well as help train up better algorithms in the future. So the idea there would be to look at the diffraction map on top of the solve structure, and then in virtual reality, easily identify what things have been fudged. Like if they just added some ligand where there's not really any density, that happens a lot because it's a grad student that's just like, I totally crystallized it with this ligand and it should be there, so I'm just going to say it is. And I don't know, maybe they kind of saw something and then just guessed, or maybe they just wanted things to move quicker. But unfortunately, there's a lot of this, corrupted type of data. So yeah, you could kind of gamify that, and you could have challenges for auditing the PDB files and thing, because that's
scores.
You need a lot of
Right?
human
People get
input
scores.
to analyze all that. Where you look at it and you just say that doesn't look right, and it's immediately obvious in virtual reality, but it's not really obvious in 2D. You could be using Coot and kind of rotating your mouse around like Dave, showing people he's busy doing something. Busy. Right? You could be doing that all day. And
they're busy.
Yeah,
still be really
busy. Well, especially in something as large as a protein. With you've got the protein atoms and the electron density on top of it. That's a lot to look at.
Yeah, in 2D, man, I don't understand that well. Like the first time I saw Coot, I was like, how does anybody understand this? And you have this sort of three-dimensional blob array, and oh god, it's so complicated. In virtual reality, it's amazing. It's perfect. I love looking at diffraction structures in virtual reality. It's just the blobs and the densities make so much sense. And whenever there's something that doesn't line up right, it's immediately obvious. So you can see, all right, solve structure, density, great. Okay, why is this density over here without a solve structure? Why is this solve structure without a density? Like, it just makes so much more sense when you could have that full stereo understanding.
And when you find you can see that a lot better when you can zoom through the structure, because they're large too. A lot of these places where there might not be density is a small blob compared to the largest blob that's the protein. But with the virtual reality, you can zoom in quite quickly and see different detailed areas.
You can zoom in, even moving the density. So let's because it's like an infinite density type of situation. So if you just had everything and break out the graphics, and it just wouldn't be a fun experience. So you kind of have a volume in space with your density in there, and then you can reach and grab it. And then instead of grabbing and moving the protein, you're moving the density around the protein. And so you kind of have this flashlight looking at particular areas of the structure at a time in 3D. Or you could just grab the protein and zoom in and make it big. But yeah, you kind of work with all that, and then you vary the like sigma values of your density, and you could overlay multiple densities on top of each other. So I'll put like a 5 or between 4, 5, 6 sigma type of density, really solid, really small. Then I'll have some less accurate type of densities and maybe opaque color, and you get in, you're just like, okay, this is so it just makes sense. I'm gonna keep saying that. You have epiphanies immediately. You go in the headset and things look how they're supposed to look, and you just immediately see what's going on.
I guess it's like akin from going from 2D to our current 3D representation on a computer monitor. You get the same increase in understanding going from that to the actual 3D object.
I'd say bigger because well, oftentimes on the screen, like we're moving on video here. We kind of have all these little head movements, and I think we built pretty good 3D maps of each other with all that movement in the same way you would rotate the protein. But yeah, the protein is a big ball of spaghetti that has a lot of complexity, and it doesn't move on its own without you telling it to move.
Yeah. Well, just to be clear, my 3D representation has a lot more hair than my video is currently showing. I just want to not quite as lush a head of hair as you have, Steve, but I can dream. The whole going into the VR and you saying it makes sense. this feels like it could be abstracted backwards. Like this feels like a learnable thing that a machine could be able to discern right from wrong, giving user intervention. So I could actually probably bring it all the way back to like a ProCheck function, where it's now, instead of me having to go into the VR, I just take the VR informed machine learning strategy and run it against my tool,
Well, I think this goes
against my
into
structure.
like the human audit or like the human in the loop process, because there's all these news articles, AI powered layoffs, companies are replacing their workforces by AI. I don't think we're at that point where scientists could just all be replaced, because if you just tell the AI to do everything and it actually does everything and it makes drugs that work and don't kill people, yeah, sure, or the scientist is out of a job. But I don't think that's going to happen anytime soon. You're going to have the AI coming up with great ideas, and when it has things in 3D, let's just say it's one of those generative molecule type of machine learning programs. You're not just going to order everything that it comes up with. If you do, you're going to be probably bankrupting your startup. You have hundreds or thousands of compounds, and you're either synthesizing in house or hiring a CRO to do that, and it costs a lot of money. But if you look at these compounds in virtual reality and just do an audit and say, is this compound any good? Yeah, you could glean certain things in 2D. Like if you're an expert medicinal chemist and just look at these AI generated compounds in 2D, you'll kind of know which ones are garbage. But there's still going to be some that are questionable. And when you look at them in virtual reality, you answer a lot of those questions. And so you could get, even more of a selection down before actually synthesizing. So right now it's about human and computers working together very effectively.
Yeah, no, my point was really just you were so effusive about, I look at the density. I try and avoid looking at densities because densities confuse me. But you were very, very visceral reaction there about how it kind of just made sense in the VR. And I just wondered, right, that kind of thing, I imagine you could encode into a model so that I don't have to go into the VR. I could just run it as a post-processing check against my structure. Right. That was,
Well, I mean,
that was,
just sort
that
of
was
like,
the observation.
the difference between the observed map and the computed map.
Yeah,
Got
exactly.
a bunch of atoms, make a computed map, get the actual map, take the difference. When the
Yeah.
blobs are big, there's issues, right?
Yeah, exactly. I mean, as much as I love the discussion, especially the future looking discussion about AI. The reality is, this morning I just wanted to set a timer, and it heard, timer 30 minutes 30 seconds. I just wanted a 30-second timer. Do you know what I mean? So AI taking our jobs, I don't know. I feel okay about it for the moment. But I guess that could actually bring us kind of towards the end of our discussion, because we're getting there. But you alluded to kind of Jarvis and a voice assistant, and I understand that you have a component of your platform that is like this now. So maybe tell us a little bit about the evolution of that and where that is. And
yeah, from day one, pretty much, we've always been interested in the AI assistant component. We've been nanome.ai as a domain. We've had nanome.io for a long time, and we even have nanome.com now. But we're still nanome.ai because I really think AI is going to be the future of everything, and I think that we're seeing that world emerge. But really, it's that collaboration between humans and computers. So we focus on the human interface for molecules in the nanoscale. And a lot of that comes down to what we see, what we can interact with our hands. Unfortunately, there's no smell and taste or anything like that. But we do have the ability to talk with the system. And we've had that for a very long time. You could say select chain A, color it red, show ball and stick, show surface, kind of things that you could click on. You could just shortcut it with your voice. And I thought that was, pretty good, but I always wanted to go with a full Jarvis AI assistant. And we didn't have the technology to just kind of build this all from the ground up. We would have had to invent our own LLMs and, have our own chat GPT, open AI company within the company. And that's just way too big. But about a year and a half or so ago, when it was very clear that these LLMs were getting very advanced, large language models from OpenAI specifically, ChatGPT 3, coming out was a huge milestone. We've been looking into it and trying to integrate the latest and greatest with LLMs in order to build this scientific research assistant. And so we just launched our scientific research assistant at the end of last year. We call it Mara, molecular analysis and research assistant. And right now it's mostly a 2D web browser that you could, type to, or you could use, voice to text to interact with it. It could spin up a variety of tools. So it's an agent-based architecture where the Mara agent is able to use scientific calculation tools, chemical property prediction, structure similarity search. There's sort of a bunch that it could do, but you could interact with it through natural language, whether that's talking or typing. So right now, as a web browser in VR, you could have Mara. Mara is eventually going to be a full-on AI embodied avatar, native in the application. But we're going with this sort of web native first aspect to it, and then going for the full virtual reality port. But yeah, it's already emerging as a Jarvis by just combining the latest and greatest LLM tools. And it's not just ChatGPT; it's Llama and all these other LLMs that are out there. I think they're just going to keep getting better and keep getting more ubiquitous and everything. And then, you just talk to it and it actually does real calculations for you. It will actually find you structures similar to the protein you're looking at. It'll actually give you the chemical properties. So it's, much more advanced than it used to be. But of course, we want the full on experience where you say, find me a better molecule. Okay, can you present this in a way that highlights the interactions? And it just figures out what you want it to do and it does it. And that could be a very abstract thing, right? Am I going to be showing the transparent surface just in the binding pocket and then show a 5 angstrom selection of all the surrounding residues and then, draw upon all the chemical interactions with little dotted lines? That's probably what I do if somebody asked me to highlight that. And you can put that in as a macro, which we have right now. But again, the ease of use by just talking to the system and it doing what you actually want it to do without having to click on a bunch of buttons, without having to do macros. I think that's going to make this a much more efficient way to develop molecules.
Definitely. We spend a lot of time teaching people how to, load up the protein and get to a point where you can see something you understand.
Mm-hmm.
So actually, maybe the last thing is, how would someone go try this?
Yeah. So we are available on pretty much all the major virtual reality, mixed reality devices. So that's going to be the Oculus / Meta Quest program. So Quest 2, Quest 3. I think the Quest 2 is a couple $100. Quest 3 is $500. Great headsets. All the HTC headsets, 5Focus 3, XR Elite. Anything that you could connect to a Windows 10 computer for virtual reality. So this could be things like the Vario or the Pimax, just like random headsets that you might already have. Just go on Steam VR or go on Oculus and you could download Nanome, try it out today. Or if you really want to get serious and you are a biotech or pharmaceutical researcher, reach out to us. hello@nanome.ai, and we'll set you up with the demo. And we could actually show you Nanome. We'll have our application science team help you out. If you have structures you want to see, we'll help import them, show you how to do that. And you can get started right away today.
I'll be honest,
Excellent.
Steve, there's likely going to be cut from the podcast. I reckon Joanna's doing a nut now. She's like, what? No, we're not going to tell them about it, how to get access to software.
Well, I think we should. I mean, we can put it in the comments, right?
I think I'm just kidding. I think we should definitely leave it in. I actually think it's a very on-brand thing for us to do. I remember when I joined CCG, Chris, in 2018, the first picture I saw of you for the very longest time, I think this may have been your Slack avatar, was you wearing a Schrodinger t-shirt. And I thought that was fabulous.
Oh, yes.
The other way you could do is you go to 3 Decision Disk Engine, and I think they still have it. There's an open in VR button, and that will take your whole Disk Engine session, and it'll open it in Nanome. So there you go.
That's good to know, because Disk Engine is...
That's just beautiful.
That is beautiful. Yeah.
Thank you, Steve.
We know about Disk Engine.
Yeah, great team. I'm actually going to meet up with them. They're coming in town this week. So Friday, we're going to catch up. But we've been working with them for a while. And now they're a part of your team. So still like working with them. Great team.
Despite the fact they're part of our team.
As a codicil, be like, even though they've joined you, they're still okay.
They're still great. That hasn't changed.
That's awesome. Steve, thank you so much, mate. That was absolutely fabulous. I absolutely loved hearing the story and the evolution of the platform. I wish you and the team just absolutely, all the successes. It's great stuff. Thank you.
Thanks.
Very
Yeah,
impressive.
appreciate you all having me on here and chatting about the current state, the past of everything we've been doing, and the future of science, and how everything's emerging with modern technology.
Very awesome. Okay.
Yep.
Thank you very much, Steve. Thanks, Dave. And I guess we'll just sign off for now. Everyone have a good day, and keep safe and keep enjoying the science. Bye for now. Thanks for listening to this week's episode of Under the Surface. Don't forget to subscribe to our podcast on Apple Podcasts, Spotify, and other platforms so you don't miss an upcoming episode. Enjoying our podcast? Please rate and review us on Apple Podcasts and Spotify. Have topics or speaker suggestions for future episodes? Send an email to podcast@chemcomp.com. That's podcast@chemcomp.com. Until then, keep exploring, keep learning, and keep loving the science. Signing off.